This video is about extrema, which is meaning minimums and maximums on a function. So you have absolute mins and maxes, as well as relative. I'll explain the difference. Min and max. So absolute minimums and absolute maximums, relative minimums, relative maximums, and these are called extrema, or extreme values. Highs and lows on a graph is what we're referring to here. So on a closed interval, they can occur on the inside of the interval or on the endpoints of the interval. So let me show you some examples. So when I say closed interval, I mean an interval like this, a, b, versus an open interval, a, b, where we don't include the endpoints. This is including the endpoints. So if you had a function whose graph looked like this, so this is your interval beginning here and ending here, you can see that you have here a minimum here, an absolute minimum, and you can see that you have a maximum here. And when we talk about mins and max, we're talking about the y values. So you know, if I was putting this on a grid, you'd go over x and up y. This is the lowest that you're going to go at any point on this interval, and this is the highest y value you're going to have. And that's what we mean by mins and max. And we say absolute on this closed interval because there is nothing lower than this and there is nothing higher than this. Okay, another example, a function could look like this. This is open-ended. These are open circles, and then you have the absolute min is still here, absolute min, and there is no max because this is an open interval, and you're approaching this value, but you're never reaching it. So there's no actual maximum value because it's an open interval. Okay, so this has an absolute min, absolute max. This has an absolute min, and there is no absolute max. So there's not always a min and a max. Here's a case where there's neither. You could have an open interval like this, and this could be open as well. So you're approaching this value from the left and the right, but you're never reaching this lowest point. So there is no min and there is no max. So there's not always an absolute min and an absolute max, but when there is, it's on a closed interval like this here. Okay, so those are some examples of that. There's EVT, which is the extreme value theorem. Let me write that. Coming from the word extrema, extreme value theorem. It's like IVT. We talked about intermediate value theorem in the past. It's an existence theorem. It doesn't tell you what it is. It just tells you that it exists. So let me just write it out for you. I'll do this in another color. So if f is continuous, so we're talking about a function. It's a continuous function. There are no breaks in it. On a closed interval, like AB, then f has both a min and a max. And that makes sense. If you're on a closed interval like you can see here, with a beginning and end, and you're on a continuous function, it has no breaks in it, there has to be a high point and a low point. And that high point could occur at the endpoints, or it could even occur in the middle somewhere. You could have a function that looks like this, that's continuous, and you can see here that the max is on the inside of the interval, but that the minimum is at the endpoint. So it usually occurs at one of the endpoints or somewhere between those 2 points. But EVT just says that if it's continuous on a closed interval, then it has to be an extreme value. Okay, it doesn't say what it is, it just says that it has to be. So that's EVT. On an open interval, you have what's called relative extrema. So if you had something that looked like this, and it went on forever and ever, you can see that these are extreme values here, but they're not absolutes. This is not the absolute lowest because the graph goes lower here, and this is not the absolute highest because it goes higher here. So these are called relative. This is a relative minimum, and this is a relative maximum, not an absolute, because you're not on a closed interval, you're on an open interval where it keeps going. And it's important to note that the derivative or the slopes at these points are 0. Okay, because you're increasing here, you have a positive slope, then you round off to 0, and then you go negative. So this is, and these points have names, they're called critical points. And that's usually where you'll find your mins and your maxes at the critical points. So the slope is 0 at these points, or the derivative is 0, and they're called critical points or critical numbers. Okay, so the only thing left to talk about here is just to show you an example of, let me add another page here, show you an example of finding on a closed interval, finding the minimum and the maximum. So I'm just going to write out the steps real quick so you can see it. How to find extrema on a closed interval. How to find extrema on a closed interval like AB. So step 1, find the critical numbers, and by that I mean set it equal to 0, set the derivative equals to 0 on AB. So going back to the previous picture, basically you're saying, where does this thing, so you're on a closed interval, where does this thing have a slope of 0? So find the derivative, set it equal to 0. Plug in those critical numbers into the original function f to see what y value you get. So to say to find y or f of x. 3, plug in the endpoints. So that's this point here and this point here, into f also, into f, and find y or f of x. So now at this point, with this example here, you'd have 4 points. You'd have the y value here, the y value here, the y value here, and the y value here. And then just look for the lowest and the highest. So the lowest y value, or the lowest number that we get, is the minimum y value, and the highest is, of course, the max. Okay, so let me do an example so that we know exactly what we're talking about here. So, example, f of x equals 3x to the 4th minus 4x to the 3rd, and we're on the interval -1 to 2. Okay, so we take the derivative, which is easy enough to do. F prime of x equals 3 times 4 is 12x to the 3rd minus 12x to the 2nd. I can factor 12x squared out of this. We're going to set this equal to 0 to find the critical points. Where is the slope equal to 0? So if I factor out a 12x squared out of this, I get x minus 1, and I want to set this equal to 0. And now I can easily see that if x is 0, this would equal 0. And if x was equal to 1, this whole thing would be equal to 0. So these are my critical points, so critical numbers. The endpoints are -1 and 2. So the minimum and the maximum occur somewhere, either at these endpoints or at these critical numbers, just like you can see in this picture up here, either at the endpoints or the critical point. So what I want to know is, going back to my original function right here in orange, what is f of -1, which is this endpoint? What's f of 2, which is the other endpoint? What is f of 0, which is a critical point? And what is f of 1? And so, cut off here, I plug those in, and I've already worked this out. F of 0, when you plug in here, 0 becomes 0. F of 1 is -1. F of -1 was 7, and F of 2 is 16. You can check this by plugging those in here. And so the lowest y value I get right here is a minimum. So the minimum value is 1, -1. And the maximum occurs at 16. That's the highest y value you're going to get on this interval for this function. The highest you're going to go is 16. And so that's 216. So there's your min and there's your max. So that's how you find an absolute minimum and maximum on a closed interval.